Hey Dale, I'm making this one for you, and for anyone else actually that needs help on this problem. But you asked for number 39 on the 7-4 challenge problems, so I'm going to work that out for you. Okay. Now, obviously you could have used a calculator, but I'm sure I would have said no calculator on this one because I want you to examine, right, the problem. So and understand the evaluation of the log statements. All right, so this is number 39. Okay, and this was the problem. Find, and they gave us a long string of expressions. So we said log base 3 27 is our Brock, plus log base 9 27 is that Brock, plus log, I think I forgot one. It's log 27 of 27 plus log, I'm going to run out of room, 81 27, and then plus log 243 is the base, okay, and the Brock's 27. Okay, so what we have here is a string of expressions where we have to evaluate each expression and then add the sum total. So remember, the evaluation of a logarithmic expression is simply the exponent to which you must raise 3 to get to your Brock. Well, in this case, it's pretty simple. But I think it's best if we approach this by, we're going to separate the terms and evaluate. And I'm going to do that a little at a time because, you know, this can get really junky and hard to read if I don't do it like this. So I think we got to be kind of creative in our thought process here. All right, so let's break it down. So I'm going to take this first expression and I'm going to put it over here, okay? And we're going to do this for every single expression. Log base 3 of 27. Okay, well, we already have a base of 3 and a Brock of 27. Well, you know, this is easy. 3 to the third, because this is our base. We're trying to find out to what exponent must I raise 3 to get 27. Well, this one was super easy. So the evaluation, and so we're just going to say the value over here of this expression is the exponent, and sometimes the exponents will be fractions, okay? But the exponent is the actual value of that logarithmic expression, because remember, the logarithm is the exponent of the inverse, and that's what we've calculated here. Okay, so that value's 3. All right, you know what? I'm going to go to the next page because I need a little more room. Okay, so just draw an arrow, and we're going to go to the next page. We're still breaking them down little by little. Okay, so the next one that we have is log, let me make sure I wrote that down right, hold on. Log base 9 27. Okay, so log base 9 27. Okay, and we're going to look for a value for that. Okay, so obviously you cannot raise 9 to a power to get 27. So we've got to figure out, what do we do to 9 to get it to a value that when we raise that value to an exponent, we'll have 27. Well, let's look at it like this. Okay, 9 to something doesn't equal 20. That's what we're trying to find out. But there's nothing in our minds right now that says, okay, you could figure that out really quickly. I mean, some of us can, but anyway, here's what you would look at. You'd say, okay, well, you know that the square root of 9, and you know that the root in a square root is 2, and when that would equal 3. And you know that 3 raised to a power can be equal to 27. Well, that power is 3, so now we have an exponent there. All right, remember, when you have an exponent and you have a root, you have the makings of a fraction, or what we call a rational exponent. So what you're going to say now is say, okay, we took the square root of 9, means root 2, and we raised that value to 3. So in essence, we have 9 will be raised to the exponent over the root, because remember, the roots grow underground, and the exponent will stay upstairs. So 9 to the 3 halves actually does equal 27. So the value we're looking for in our second expression is 3 over 2. So like I said, sometimes you're going to have exponents that are rational, okay, which means they're fractions. All right, let's look at the next statement. All right, so I'll just separate that out. The next statement is log 27, or the next expression, excuse me. Well, this is easy because you know that 27 raised to the first power equals 27, because 27 to the first equals 27. So the value we're looking for that expression is simply 1. And you know we're adding these as we go along. Okay, so I'm going to move to the next expression, probably the next page. I like to write big, so that's why I have so many pages. That's why I record this, so you can go back and stop. All right, so the next expression, and again, you could compress this. Doesn't have to be 3 pages long like mine. You can do it all the way out, but I just want to go slowly and show you. All right, the next expression is log base 81 BROC of 27. All right, the value that we're looking for is the exponent that we're going to use to create and turn 81 into a 27. All right, well again, you look at that, you go, well, I can't raise 81 to a certain power at the top of my head and know what it is at 21 to turn to 27. So you're going to take it separately. So we're going to look at this and we're going to say, okay, I can take the 4th root of 81. So here's my root. We're going to need that in a second. And I know that the 4th root of 81 is 3. And you know that 3 to the 3rd is 27. All right, so 2 things. We took the square root of the base. We took the 4th root of the base, and then we raised it to a power of 3. So here's the exponent, okay, and here's the root. So what you have is the 81 is our base. We are raising it to a rational exponent. And the top part is the exponent of the 3, which is 3. And the root is going to be the denominator. We learned this when we learned about rational exponents. So the value of this logarithmic expression is the exponent that we would raise 81 to. And so that would be 3 over 4. All right, and the last expression, and again, you can do this in a much more rapid scale, but if I ask you to not use a calculator, this is what the thought process is. Okay, but I just want to go over it slowly because this can be a little confusing. All right, log base 243 BROC 27. Well, again, you're looking at a base of 243, and you're like, what can I raise it to get me a BROC of 27? Well, we have to kind of dissect the base. So we say, okay, I'm going to take this, I'm going to put it under a radical, and I'm going to take the 5th root of this because I have to take a root that will obviously give me an integer, and I have to take a root that is meaningful. Well, it's only meaningful if I raise it to a power and it gives me my result. Okay, so if we take the 5th root of 243, because remember we're aiming for the BROC, so that's going to give me, lo and behold, a 3. And then we can raise that 3 to the 3rd power to equal 27. So the base of 243, remember, here's your exponent, here's your root. We're going to build a rational exponent, and that's going to be the exponent part over the root part. So 243 raised to the 3/5 power. This is our ending value because remember the exponent to which you raise the base to give you that BROC is the value of that expression. So now we're going to add all of them from start to finish. Okay, and I'm just going to make a sentence. All right, so it's going to look like this. Okay, our first expression gave us a value of 3. Our second expression gave us a value, a rational exponent of 3 over 2. Our third expression gave us a value of 1. It was 27 to the 1st power equals 27. Then we figured out that we had a rational exponent here. Remember, these are all the exponents to which we raised our base. Okay? Sorry, that's my printer. Okay, and then we had a last one which was 3/5. So if you add them all together, and I want fractions, not decimal, and not mixed numbers. Okay, this is what I would have expected. Now obviously, you could double check that by putting all of those expressions, the whole lot of them, into your calculator and added them all together. And you would have had math enter, and you would have been left with 137 over 20. So you could have put all of these individually into your calculator and double checked it. Okay, they're non-base 10 logs, but we have a feature that allows us to do that now. Okay, sweetie, well I hope that helped, and of course, Dale, I'm calling you sweetie. I mean, anybody who wants to watch this video. But the answer to that is actually 137 over 20, or I think they gave it in some weird mixed number. All right, hope that helped. Have a good weekend.